And now we're going to go to the second part, which is the economics evolution. We talked about economics in the previous lesson, do you remember? In general, economics is a science. It's a study of how to allocate resources, how decisions are made, what are the best alternative to create the best utility or create the best benefits to everyone in the economy or in the ecosystem. It's always about the allocation of scarce resources. And that is the behaviors that we're talking about. How do we allocate them? How do people react to this allocation? And we can enforce these behaviors by two things, incentives and disincentives, which are punishments. So this is the core of economics that I talked about in the previous lesson, that economics is about incentives, punishments, and behaviors. Now, based on that, now we want to understand how economics has changed and evolved thanks to technology. So we move from a non-digital physical ledger to a digital 1.0 central ledger to a digital 2.0 decentralized ledger. So each new field in economics seeks to understand new variables in the ecosystem and how they interact with each other and how do they affect different stakeholders in the ecosystem. So traditionally, in the non-digital physical ledger, traditional economics studies the production, distribution, and consumption of goods and services. We'll talk about that more in details later, but in general, it's just to understand with physical ledger, with the basis of economics is how to produce, consume, and distribute the goods and services. As we move on to centralized ledger or the digital world, we come into this new asset or new variable called intangible asset that we talked about. So this could be intangible information, data, asset, something that's really intangible. So with a digital 1.0, from a central ledger point of view, we want to understand how these new sets of variables affect the production, consumption, and distribution of goods and services. Because it's no longer physical goods, it's no longer producing water bottles and fruit and markers and laptops and cash even, hard physical cash. Now we're looking at a digital version of many things and trading information, trading data, instead of just trading physical assets. And then in recent years, we are looking into this thing called a decentralized ledger, where it's still digital, but instead of being governed by a central authority, it's now governed by a decentralized authority, or decentralized community or organization. And that's where token economics comes in. What we want to understand is the variables that affects, defines, and governs the ecosystem. Because now it's decentralized, how do we coordinate people to work together? How do we coordinate participation? How do we make sure people cooperate? And how are actions governed in this ecosystem? Because it's decentralized, things are a little bit different compared to the centralized world. We still have to take in information economics and traditional economics into token economics. Don't forget that. And one of the biggest change is that we have evolved from economics of scale with the physical ledger, which means by producing more, you reduce the marginal cost of each one, because you get to split the fixed cost to more items that you produce, physical items. And now we have moved from that, which is economies of scale, to now economies of network. You hear a lot of time people talk about network effects, how do you build your network, how do you build your community, how do we increase the network, and that's all part of the decentralized or the digital world today. So what we want to understand is as we are talking about the economies of network, we want to understand how to coordinate them, how to allow cooperation, and how to allow participants to work with one another. So as I mentioned in the past, economics was about the production, consumption, and distribution of goods. And they're usually, more often than not, physical goods. And how do we understand, what does that mean, like production, consumption, distribution? So we always have this graph. Don't worry, I'm not going to talk more about this graph. This graph is just trying to say we're looking at equilibriums. We're looking at when two lines cross each other. That's what we call equilibrium, and we want to start producing that. When it comes to physical goods, you see the MC and MR curve. MC is the marginal cost, MR is the marginal revenue. And what we want to do is to make sure to stop when the marginal cost equals the marginal revenue. So what does that mean? That means if let's say we're a gyoza shop, okay, we make delicious gyoza and we sell gyoza, and the cost to produce one plate of gyoza is 50 cents, and the cost to produce this plate of gyoza is 50 cents, and the revenue I get from the gyoza is 50 cents. Now, when I produce one more gyoza, the cost is slightly different. The cost now is 55 cents, and my revenue is only 53 cents, and I lose 2 cents, or my cost is now more expensive than my revenue. And that doesn't make sense, right? You want to only produce when your cost equals your revenue, or your cost is less than your revenue. If your cost is more than your revenue, you don't want to produce anymore. So that's when we stop producing. So what the graph is trying to say, this graph is trying to say, is that we want to stop producing when it's the cost you produce one, the cost of producing the extra one equals the revenue of the extra one. So that's quite easy to calculate, right? It's like, okay, that's all very nice, very good, easy to calculate. Look at when two lines cross, find equilibrium, get the price, get the quantity, done. But it's slightly different today because now we're looking at a digital space. We are no longer talking about physical information. We are moving to a digital space with information, with data, with intellectual properties, and it's slightly different today. So, as I mentioned before, the digital world talks about how we understand this new sets of variables, how information and information systems affect the economy and economic decisions. So that means we're going to look at new types of pricing. We're going to look at types of how to signal, how does licensing, lock-in, and network effects all affect the whole valuation of an ecosystem, or how decisions are being made. So going back to, so what's the main difference between traditional economics, as I mentioned, and this new information economics? The main difference is that it's very costly to produce in the information economics, or in the information world today. It's costly to produce and costless to reproduce. What do I mean by that? We talked about gyoza just now, right? Me manufacturing gyoza, and then selling to whoever that wants to buy gyoza. But look at this. What if instead of me saying, I don't want to make gyoza, but I want to be teaching gyoza, I want to start creating tutorials, having lessons, and teach people how to make gyoza, then how does that work? How are we going to price that? I'm creating a recipe or a video recipe and teaching people how to do that. So the difference is that to make this video of how to create or how to make gyoza, it's quite costly to produce. I need to buy the equipment to film, I need to edit, I need to buy the software to edit, to cut, to put things together, and then to distribute and create gyoza content. But it's costless to reproduce, if you think about it. If you want the recipe, I can just send you the recipe. If you want to share this video recipe with someone, you can just copy and paste the link. You can just share this recipe with anyone you want. And I don't need to remake this entire video. I don't need to be filming, cutting, editing, and reproducing this video again. So it's a lot costlier to reproduce, but it's costless to reproduce. So the cost of information now has a very new structure. Previously, when we talked about making gyoza, we have to buy there's still fixed costs, right? We have to buy the frying pan, we have to buy the bowls to make gyoza, which we still do. We still have to do it in this tutorial content. And then for every person that wants to order a plate of gyoza from me, then I have to go into the kitchen, defrost the gyoza, or make the gyoza, fry it, cook it, and then serve it. This one, whoever that wants to learn how to make a gyoza, I can just send them the video. So it's basically almost free to copy and reproduce, and there is no natural limit. There's no natural capacity. if 1 million people want to learn how to make gyoza today, I can just send this to 1 million people, or 1 million people can go to a big screen in a cinema and watch it. Whereas if 1 million people wants to eat my gyoza today, I have to be making 1 million gyozas a day, and I don't think I can make 1 million gyozas a day. So with digital data and digital information, there's no natural limit. And because it's almost free to be reproducing, the cost structure just differs. We don't have the nice curve anymore because we have a very high cost, and every marginal cost is basically zero. So if we take this video, for example, I told you I took almost 2 to 3 months to create this video and create this content, referencing a lot of books, and at the end create this piece of information, a tutorial video. So it's very costly to produce because it took a lot of time, took a lot of initial startup costs, a lot of reference to books and papers and articles, and talking to different people to get feedback. Whereas to reproduce it, to share it with someone, every time I get a new student, I can just send the link to the student and the password, and all the information can be shared with a simple click. So that's one of the biggest difference, which is the difference in price structure, which we'll talk about later. But before we go and talk about the price structure and how it differs today, let's understand a little bit more about the difference in resources or assets. So we have tangible to intangible. Tangible is the physical gyoza that I make. Intangible is the recipe or the video tutorial that is being shown just now. So firstly, the cost. With tangible resources, now you have a lower marginal cost compared to intangible resources, and then you have a higher marginal cost because to produce an additional plate of gyoza, maybe it's 50 cents, whereas to send the same video to share it with someone else, it's basically free. I just have to copy paste the gyoza recipe link and send it to my friend. But there's a comparatively higher fixed cost. When it comes to limit, there is a natural limit because I can't make 1 million gyozas a day. So there's a natural limit to how much can be produced. Even with machines, a machine can only make so much in a day based on the speed of production and the efficiency and stuff like that. When it comes to intangible resources, there is no natural limit. I can send it to whoever I want to send it to, how many people can watch it, and it can be enjoyed by as many people as possible without decreasing in the quantity. So, for example, I can make 1 million gyozas a day, and the first 500,000 is probably going to be quite okay gyoza, but the last 500,000 is going to be really tiring. I don't want to make gyozas anymore, but probably the quality decreased because people are demanding the gyoza. Whereas with intangible resources, I'm making this video, you're watching this video, more people are signing up for the course and watching the video as well. And by having more people coming to watch, it doesn't decrease in the quantity you produce. Just like going to a movie. Having one person in the cinema, having 1,000 people in the cinema, having a long queue for people waiting for the show to start, doesn't decrease the quality of the show at all. So there's no natural limit to how much it can be, and the quality will always be there at the same level. When we talk about how do we value resources, with tangible assets, we usually value them based on the different cost. So how much is the raw material for the gyoza skin, the gyoza filling, the oil, the electricity, my time, my effort. Together, you get a general cost to produce the gyoza, and then you can just put a markup based on it and sell your gyoza. Whereas with intangible asset, the cost depends. I know I mentioned that the cost doesn't depend so much on money or the fixed cost that we created or was used, but now the cost is based on consumer value. How much the consumer value this item, the age of information. So if I were to say that I'm making this course 30 years ago, there is no value to it because no one knows what I'm talking about. Or maybe 50 years later when all this information is out there and there's no value to it. Or time frame. So now might be valuable in the next, as I mentioned, the next 50 years it's not going to be valuable. Or in the next 50 years, that this information will be outdated. So the value really depends on a lot of different circumstances, and it's not a static number. It's a bit harder to value, but a lot of people are trying to work on this. And what happens when the resources are being sold? When my gyoza is being sold, I don't have the gyoza anymore because I exchanged the gyoza for money. Whereas when I sell for every of this, when someone comes and buy the course and I sell the course, the information is still in my head. The information is still with me. Just because I sell this knowledge or this token economics resource workshop or module set to someone else doesn't mean that the information is just gone from my head and disappeared and transferred to someone else. So an example will be information products like books. You've got paperback, I don't have it now, but you've got like hardback book, you've got paperback books, which is the soft cover. Oh, I do. So you've got like hardcover books, which are usually a lot more expensive. Then you have soft cover books, which are cheaper. And then you've got ebooks, and they're usually a lot cheaper, sometimes even free. So these products are the same, they have the same content, they're all information products, but the price is different depending on how consumers value it. So with physical books, hardback or paperback, soft cover, it's physical, so we have to consider the production cost. And with ebooks, it's slightly different because it depends on all the information, how consumers value it, the age of information, time frame, and everything. It's usually cheaper than the physical books. And so what we see here is that technology has changed the way economic principles are being applied. We still have to price things, we still have to value things, we still have to understand the cost, but the way we do things have changed. So the key principle here is that the core concepts of economics doesn't change. We still have to be valuing things, pricing things, understanding the cost of things, but the way of it being applied has changed. So what we talk about pricing things, and for information of intangible assets, we're pricing things very differently now. We price them based on value. Cost-based pricing doesn't work anymore. We need to start pricing based on consumers' value, as I mentioned before. So what types of values are there? There are three types of value. The first one is the value of network. So this is Alphabet, which is also part of Google, which Google is also part of. It's this big company, and they have so many different entities and partners in their network. And they build a network it's almost like an ecosystem where they can rely on each other and they can help each other to grow and allow ideas, creativity, resources to be shared in the network. So that's one of the, in addition to everything that Alphabet and Google owns, the value of the network that they exist on their own also helps to add a lot of value in monetary terms. The value of externalities is also very important. So they're all linked together. So when you have networks coming together, you can have idea synergy, you can have collaboration, you can have idea spillover. Something that probably works for YouTube, the same concept might be able to be done in the different, maybe in Nest or somewhere else, or some stuff in Nest can be used for Android or Access and NG, and there are a lot of ways that ideas can collaborate, ideas can spill over, and this is where synergy comes in. This is where you hear this 1 + 1 = 3, because you can have more value by collaboration, by working together. So that adds a new set of value, or new level of value. And lastly, I'm not going to talk about Libra, but I'm going to talk about the value of partners. Similar to network, so the value of network is just network. You create your own network. It could be stuff that's under your subsidiary, or you can have communities and stuff like that. Value of partners is where you don't own each other. Technically, you don't own each other. You just come together to collaborate. And with Libra, that's what you see. You have a lot of these big partners or big corporates and companies coming together to work together and try to make this a success. So values, they're all interlinked, and value of partners, value of network, and value of externalities. And they all come together to help each other to collaborate, coordinate, and create new things. And now we move on to the last part of the new economics, which is the decentralized digital economies. So it's moved towards digitization. Information economy continues to grow, but we're also moving the way our economy works, because with information economy, as I mentioned, was still very centralized. Now we're looking at decentralized digital systems, decentralized economies. And one of the biggest there are a lot of challenges that will arise. And one of the biggest challenges is, how do we understand the variables that affects the ecosystem? How does it affect the participants in the ecosystem? And how do we govern such an ecosystem? Because now people are from everywhere. People are decentralized. How do we coordinate all of these activities? So something that's quite big these days is this thing called decentralized governance. Decentralized governance is meaning everyone has the right, or at least the opportunity, to have their voices be heard and challenge the trajectory of the ecosystem. So you can vote, you can partake in different kind of communities, decentralized communities to govern, or they have different layers of governance that people can join. And now we have to consider more about encouraging good behaviors in the ecosystem and not just allow one participant to ruin it like a bad actor. Because a small minority could bring the entire thing down, or maybe you've got what they call whales or big players in the ecosystem. They could gobble up a lot of the power, and then we go back to centralized authority or centralized ledgers again. So there's something that we have to think a lot about. And in a very general view, there are two ways to do this. One is the macro way and one is the micro way. The macro way is systems architecture, or how can we embed all these architecture into code and allow decentralization in that form, in the architecture of an ecosystem form. Then we have a micro method, which is how do we allow people to self-select? What kind of mechanisms can we put in place to encourage people to behave properly, to have good behavior, and to encourage them to work for the ecosystem instead of for their own individual needs. So that's something that we want to understand how to do, and that's something that we could do. The other thing is, because the other big question is that we need to start coordinating decentralized organizations. Everyone has different incentives. Everyone comes in with different objectives and preferences. How can we align them together? How can we coordinate agreement with all the different decentralized participants? How do we make sure that they don't end up having a bitch fight like in the little GIF here? How do we make sure that they don't start bashing each other up? How do we make sure that we can let them cooperate together? So that's something that we're going to talk about next. But first, this is a summary table of the traditional economics, information economics, and token economics. So traditional economics, to explain it, traditional economics is to understand how to put any input what you want to understand is, for every input that goes into the ecosystem, what kind of output can you get from it? So if you put gyoza paper, some oil, some meat, and fry them, which is input, the output is you get delicious gyoza. With information economics is you want to understand that, but in a digital form. So my input will be my effort to create the video, making the recipe, filming everything, and the output will be a little video recipe that can be shared with people. And in the future, which is the token economics, we want to understand how self-selecting input can get desired output in an ecosystem. So, for example, how do I make sure that people can now choose to participate in the ecosystem or not? And if should they want to participate, how do we make sure that the outcome or their output is going to be it's aligned with the view of the token ecosystem or the view of the ecosystem. So what does it mean? I don't want someone to come into my ecosystem to destroy it. For everyone that comes and join my ecosystem, I want them to add value to the ecosystem, just like the ecosystem adds value to them. So being good, working together, participating with each other, coordinating with other participants. And where does economics come in all of these different economics? With the traditional one is to understand production, consumption, and distribution, because we want to make better choices. Okay? We want to understand, okay, I want to stop producing if I produce and I make a loss, that's where I want to stop producing. I want to stop producing when my cost equals my revenue. With information economics, we want to understand the types of variables, which is intangible asset, and how do they affect the production, consumption, and distribution. So then we can make better strategic choices involving all the information technology that we have, or the intangible assets that we have, and are part of the decision-making variable or factors. And with token economics is to understand the variables that affects, defines, and governs the ecosystem. And this is to affect the decisions made by participants in the entire ecosystem. The purpose. So with traditional economics, the purpose is to analyze when to stop your input to get the output, which is when to stop producing when the cost is going to be more than the revenue. And then from there you can get your pricing structure. With information economics, we want to understand the value and how to extract the most value out of your ecosystem. So we talked about the participants, externalities, and network externalities, and partners, and how do you extract the most value out of them. And with token economics is to govern behaviors by allowing the participants to self-select and encourage specific behaviors. So for example, if we are looking, we talk about the examples here. With traditional economics, for example, we have Tesco, supermarket at Tesco. So Tesco needs to know how much to produce, when to stop producing, how to reduce the cost of distribution through efficiency in supply chain or buying your upstream or downstream, how to encourage consumption. It's all part of the consumption, production, and distribution. With information economics, let's look at Amazon. So Amazon is a platform. The platform allows buyers and sellers to trade, and they don't own anything. They just have a platform which allows coordination between buyers and sellers. So we want things to be traded more efficiently. There are some centralized rules and guidelines to follow, and they make the last call. So if there's an issue, then Amazon comes in to be the governing body to manage and coordinate things when things go wrong. And in the future, we're talking about decentralization. We have decentralized governance. So, for example, we look at MakerDAO. MakerDAO is a stablecoin, and they want to encourage behaviors such as spending or saving the currency through different mechanisms. So the rules are voted by the community, and no one has the last say. If they have two tokens, and if you have the token that allows you to vote, or you have the governance token which allows you to vote, then you're part of the governance. Otherwise, it's not. Otherwise, you can just use the stablecoin for other things, and no one has the last say because it's a decentralized organization, and everyone has equal say. So in the past, or in traditional economics, production cost is super important through optimization. We want to maximize revenue, minimize costs. We want to optimize that. So how do we do that? With information economics, we have trust in the platform, and the most important thing is the trust in the platform, and this can be done through network effects. And in the future, token economics, the very important thing will be your decentralized governance, because we don't trust the platform anymore, and what we trust will be the decentralized governance in place, and this can be done through your mechanisms.